Hi, this is Tony Northrup for TrainSignal, and in this video lesson, I'm going to cover the SSCP objective for the analysis of monitoring results. So we're going to learn how to analyze the output from your computer and networking equipment monitoring systems. First, every monitoring system provides reporting. All these events that are generated by all the many different computers are analyzed, and then the system determines their importance level. Depending on the software, they use different terms. They might be alerts and alarms, alarms being the more critical types of events. You might have multiple levels of alerts. For example, green alerts might be informational, yellow alerts might be important, and red might be critical. Some systems will use terms like verbose to mean the least important types of events, information to mean a slightly more important type of event, and then you might get critical or serious in there too. So the one thing all these systems have in common is that they assign different priorities to the different types of alerts and alarms that you'll see. Now, of course, you ultimately have control over how you respond to each of these things. So in a typical monitoring system, you'll take an event like a low disk space alert, and then either decide that you are going to notify administrators when that happens, or maybe you send an email directly to the end user with instructions, or perhaps you even launch a process, a script, for example, that might empty the recycle bin or perform some other sort of automated task. Other typical alerts you might see would include, a large number of failed login attempts, which might indicate somebody trying to hack a password, or an automated tool that's performing a dictionary type of attack. You might see a higher than normal CPU or memory usage on a computer. Now, that could be that a user is just playing a game or rendering a video or something, but it can also indicate a problem. It could be that a process has gone into some sort of loop that it will never escape and it's just using 100% of the CPU. It could be a denial of service attack being launched against either a client or server computer, causing that computer to use a bunch of resources. I know recently I've seen high CPU and memory usage as the result of a successful attack. So what people are doing nowadays is running people's processors, especially their graphical processing unit on computers, to perform the calculations that are necessary to generate bitcoins. Bitcoins are this type of online internet currency, and yes, you can just generate bitcoins with enough processor time. Now, this doesn't make any sense to do financially on your own computer because it costs you more in electricity than you can possibly generate with bitcoins. But if you hack into somebody else's computer, of course, they're paying for the electricity, so you can essentially steal the money that they're putting into the electrical system by taking their processor time and outputting the bitcoins that you can get. In other words, high CPU usage and high memory usage nowadays can mean a successful compromise in an unwanted process running on a computer. Higher than normal network bandwidth usage, of course, that can be normal. Somebody might be downloading a new update or a new version of Windows or something. It can also be the sign of an attack, because another thing that hackers will do once they gain access over a remote system is they'll use it to host files. They could be legal files, but they're often illegal files. For example, it could be pirated software or video, and you couldn't just put it on a regular web server to distribute because it's illegal content and they would track it down and shut you down right away. So they'll hack into computers that aren't protected and use them to store their files. And what you'll see is a big spike in bandwidth usage as well as disk space. You probably also want to respond to alerts for critical patches that fail to install correctly, because of course if it's a patch that's fixing a security vulnerability and it fails, well, you know that vulnerability is still active on that host. So these are some of the things that you need to monitor and respond to in a reporting system. And I'll tell you what, at the companies I've worked for, you'd be shocked how often people monitor systems but don't actually respond to the alerts that pop up. It happens. You'll walk into the monitoring station and you'll see these red exclamation points everywhere, and systems will be failing, but they just don't have the staff to respond, or maybe they're just lazy and they don't feel like getting out there and fixing the problem. So it is really common to ignore these alerts. Another point, if you find yourself ignoring a lot of critical level alerts because you don't need to respond to them, well, you should change the level of alert. You really need to be consistent about it, because if you get used to ignoring these red level alerts or serious alarms, well, when one comes along that is critical, you might not pay attention to it. So be sure to customize the alert levels to really suit how your organization responds to events. Besides alerts because of the specific events, Reporting is also used to monitor general trends. For example, you might monitor the trend of total disk space usage in your organization. You might, for example, see the trend increase as your organization begins working with multimedia. If they start to use video or images for training, you might see the disk space usage go up, and you might be able to plan your future budgets to accommodate for that. On the other hand, you might see dropping disk space usage as people move more and more items into the cloud, and you might be able to figure out that you guys can use smaller and lighter tablet computers with smaller drives in them in the future. Most reporting software will put together nice visualizations for you, bar graphs, line graphs, pie charts, etc., to make it easier to consume all this information. And I've covered the term false positive in other lessons, but I just want to reiterate, a false positive is an alarm that shouldn't actually be an alarm. It's a red flag that goes up that you can ignore. And false positives are a serious concern because if too many false positives come up, what's happening is you're training the IT staff to ignore alerts. And what happens then? It's the boy who cried wolf, right? You have too many false positives that you're supposed to ignore. A real true positive comes along and you just think, well, the last 9 positives I saw were false, so this one is probably false too. Whenever you get a false positive, you need to take a look at the reporting system and see if there's something you can tweak so that false positive won't reoccur, because it's really important that most of your positives be actual alerts. Besides just alerting to error conditions, it's important to log information on computers, but hopefully not log too much. So some of the reasons that you want to log is to just keep track of who, what, and when. This is a type of auditing. If every time somebody logs in, you should add an event to the event log. When they log out, add an event to the event log. If somebody types in the wrong password, it should be logged. If they access an important file, for example, something that's secret or confidential, you should log it. However, you don't want to go overboard. You don't want to be logging stuff that's not critical, because that'll be putting too much junk in your log files. That'll make your signal to noise ratio much worse, and it'll make it that much more difficult for you to parse out the important information from the unimportant information. Intrusion detection is another good reason to log data. Now, of course, for it actually to detect the intrusion while it's going on, you'll need to have a real-time alert and notification system set up. But intrusion detection logging is also useful for what they call a post-mortem. That's after something has happened, you figure out somebody's been in your system for 6 months, you can go back and look and see how they got in, you can identify when they got in, and now that you know when the compromise was made, well, you can go back in time, restore backup from that point, and recover your files to a point when you trusted the integrity of them. If you find out that somebody's been in your system and you don't have any log files for it, well, you don't know how long they've been in there. And therefore, there's no way you can trust your system's integrity or your data integrity anymore, because once somebody gets in, you don't know what they change. You don't know if they put on firmware rootkits or what else they might have done. So it can be a real scary situation, but it does happen a lot. Logging is also important to meet your policy requirements and governmental regulations. So a lot of different regulations require that you log every time somebody accesses, for example, healthcare records. They need to know everybody who's read those records ever. Just in case they show up on the internet or in some place where they shouldn't be, they can track back and at least narrow it down to the number of people who saw the data and had the potential to share it. Just about everything that can connect to a network can generate a log. Routers, switches, firewalls, anti-malware software, intrusion detection systems, authentication systems, security cameras, door locks, client PCs, servers. Everything out there is creating log data, and you need to make sure that you're gathering it and monitoring it. Ultimately, collecting all this data doesn't get you anything. It's about how you use it. So you can use this data to monitor your system's health and simply make sure that there are no serious errors coming on, something that you could predict ahead of time and maybe head off by going in and replacing a failing hard drive or swapping out a video adapter that was crashing repeatedly. It also helps you understand your network performance. If you monitor network activity, you can see that the increasing network usage is going to require you to add another internet circuit in order to ensure the availability and performance that your organization needs. You might also be monitoring user data, such as how many files users are using and what types of apps that they're using, so that you know whether you need to, say, purchase more licenses for Microsoft Office or expand the capacity of the database server since users are putting so much more information in there. It's also really important for kind of classic security concerns like logging incorrect login attempts, so you can know whether somebody is attempting to hack user credentials, and maybe you can go in and block that client or close a vulnerability that was allowing them to hack it. On the server side, it's really common to monitor the number of active sessions and the network traffic going to APC, as well as the processor and disk and memory utilization, to ensure that the server can continue to meet the capacity and performance requirements. Because scalability problems can come on quickly. A server can seem to be going just fine, and then it goes from 90% utilization to 95% utilization, and everything falls apart. It then starts responding way slower, and users can't get their work done during peak business hours. So the way you head that off is by monitoring it, and of course performing some scalability testing. But after your scalability testing is done and you know the max capacity, well, how do you know if you get close to that capacity? Monitoring and analysis. Of course, there are many different applications out there that aggregate this massive amount of logged data and then make it into pretty charts for you in the form of reporting, or provide some sort of analysis in a post-mortem after an event has occurred, or in the best case scenario, monitor and analyze that information in real time and alert you to issues that are currently going on. There are many different types of logs, but here are the four most common. The event logs generally monitor events that are thrown by an operating system or an application. So developers write code, whether they're apps or the operating system, and the developer will literally write a line of code that says raise event, and then they'll put in the number code for the event and some sort of useful description. Well, they're not always useful, but every once in a while a developer gives you a useful error message. So these events could be anything. It's really up to the developer and whatever they feel like doing. And sometimes if you actually go through an event log, you'll see events in there that are clearly meant just for the developer, or it'll just have some code that nobody could possibly interpret. And sometimes they put events in there during debugging because they're trying to use the events to help them solve a problem, but then they don't take it out by the time they ship it to you. So you'll see a lot of events in there that mean absolutely nothing to you. A lot of applications and operating systems also allow you to configure which events are logged and which aren't. So it's a good idea to do that rather than filtering it in post, because every event that's raised takes a little bit of processor and memory time. Another type of log are performance logs. Performance logs monitor the computer's actual utilization of resources and how quickly it's responding. So if you look at a performance log, you can see that the disk is at, say, 50% capacity, and the memory is 75% full, and the processor has been running between 10 and 80% utilization and averaging 30% utilization. Performance logs, of course, are important for planning out your future capacity needs. You can see, for example, that your website is getting 10% busier every month. Well, at some point, you're going to need to expand that or upgrade the website so that your site can stay online. Audit logs are a security guy's dream. They just monitor whenever somebody performs some sort of action that you've decided to monitor. And by default, because there would be so many different audit events, most operating systems and apps don't perform audit logging because honestly, most people don't ever look at them. But we're good security guys, right? So we want to be able to monitor this stuff, especially if regulations require us to do it. So we're going to turn on auditing. We're going to monitor failure logon attempts and even successful logon attempts. We're going to monitor when users change their passwords and when users are added or removed from groups, because these are all things that might happen in the context of a security break-in. And if you want to know what happened in a security break-in, you got to configure auditing for these types of things. So the way that you do that is different for every operating system. The SSCP certification exam isn't going to test whether you know how to turn on auditing, but I want you to know what auditing is and the ways that it can be applied. Another type of log is a change log, and change logs are closely related to audit logs, and in fact you might even use auditing to monitor the changes. But change logs can also provide additional information. In the context of a file system, a changelog could monitor every time a user changed a particular document. So imagine some top secret document that has future military plans for some kind of takeover. Obviously that information would be really critical, and of course you'd want to monitor every time somebody opened it, but it'd be even more important to monitor whenever somebody changed it, because one of those legs of the CIA triad is integrity. And if you can't trust your documents, then you don't have integrity. So you need to know who changed it and when. But there's something else. You also need to know what they changed. And most modern file systems don't have this built into it. But if you have a content management system, which a lot of organizations use, you'll be able to look at specifically which line somebody changed, and if you decide that that change isn't appropriate, if it violated the integrity of the file, you'll be able to roll back to an earlier version. These monitoring systems are generating just gigabytes and gigabytes of data, so of course it needs some management. Storage is a real problem, especially if you start to really get into the auditing, because you can't just capture it and store it for a day or however long you need to respond to alerts. You need to store it for months or usually a few years. Regulations vary, especially depending on the industry and company, but generally it's considered standard to keep logs around for about 5 years. And 5 years worth of logging can be terabytes and terabytes and terabytes of data, even compressed. But of course you'll be able to anticipate that because you're monitoring your log storage device, right? And you'll see how the log capacity is growing over time. It's also important that you back up your log files and that you be able to restore them, because there's nothing to stop log files from being lost just like any other file, right? And then whenever these log files are expired, you can get rid of them. This frees up storage space, but for many companies it can also help reduce their liability. So many companies are eager to get rid of their log files after a certain amount of time because honestly they might have done something illegal unknowingly, for example, and they'd rather not have those log files around to prove that they did something wrong if they aren't required to keep those log files. So for most companies, they keep their log files around for as long as they are legally required, and then they get rid of them just as soon as possible because, well, it just makes their life a little simpler. Some of the concerns you should have for your log files are, of course, the security and availability and integrity of them. One of the things that will happen is somebody will break into a computer system and then clear out the log files. That makes sense, right? Just like a burglar would bring a rag and wipe his fingerprints off of things. Well, a hacker will break into a system and then delete all the log files. So, of course, he's got control of the system. How do you work around this? So you set up a monitoring system that is constantly shipping the log files out to a secure remote system that doesn't allow the log files to be erased. So once somebody compromises a local host, you can't trust the log files on that local host. The guy could have changed it. He might even leave the logs in there, but say change his own IP address that appears in there just to throw you off the track so that you don't know it's been compromised. It happens. That's why integrity is such an important part of the CIA triad. It's also important that you keep your logs confidential. If a corporate spy were to get a hold of your company's log files, they could tell a lot about your company. They might know that you were considering a merger or that you're developing some new product. They might even find weaknesses in your security system, so keep them confidential and keep them available. That third leg of the CIA triad. If your log monitoring system can be taken offline, then people can get away with stuff that they shouldn't. Now, I just discussed this system where monitored host is constantly shipping its log files off to another secure host. Well, if an attacker figures this out, you know what he does? Sends a denial of service attack to that monitoring system. Then it can no longer receive the log files, and he's free to do whatever he wants on the local hosts. Now, there's often a queuing system that will keep the logs queued on the local host while, say, the monitoring system is being rebooted. But if they're queued up on the local host, then the attacker has a chance to clear them before they can be sent off. It's also important for you to have clear goals for your log file analysis because this will allow you to narrow down the amount of data that you log, reducing the storage capacity, and reducing just the amount of noise that's in there. So have specific goals in mind when you set up your monitoring. Watch out for incompatible or proprietary log formats because it's entirely possible in the future that you will upgrade to some other system that won't be able to read your current log file. So whenever possible, try to use open standards, and most of the time that means XML-based log files. Synchronizing the time on different hosts in a network is really critical. You need to make sure that every computer, router, switch, everything in your organization is synchronizing its time with NTP. The NTP, the Network Time Protocol, will keep every device synchronized, hopefully with Greenwich Mean Time, the worldwide standard for time. This doesn't mean that you can't look at time in your own time zone. Most hosts will allow you to configure the time zone and then they'll show your local time, but with a worldwide organization, your log files need to be set to UTC so that you can correlate events that happen in different time zones against each other. If you don't set the time on computers, eventually the clocks will be off, even if they're initially correct. And at that point, you can't tell whether events happened at the same time or in what sequence they happened. So make sure you set up NTP on every host in your organization. There are dozens, maybe hundreds of different monitoring applications out there, and organizations use a lot of different systems, including a lot of homegrown systems, especially for specialty internal applications. The simplest monitoring is a ping loop. I just run ping-t and then the IP address of a remote host. I do this if the host is offline and I'm waiting for it to come back up. Sometimes you're rebooting a server, and I'll just open up a command prompt and ping it so that I can see when it starts responding again. That's kind of the simplest form of monitoring. But back in the day, back in the early 90s when I was first working professionally doing systems administration stuff, most monitoring software was just pinging things. It's pretty simple, right? Ping loops aren't ideal because ping loops check to see whether basically the network adapter is responding. But it doesn't mean that any useful services on the computer are responding. So a server might respond to pings, but the web server software that you need on the server isn't actually running. Therefore, the functionality you need on the server is offline, but the server would seem to be up because it's pinging. A lot of servers nowadays also don't respond to pings just for security reasons. So the server might be up and running, but it's not listening to pings. A better thing than a ping loop is to actually connect to a network service that is supposed to be working and check to make sure that the connection is valid and that the server is returning a proper response. So instead of using a ping loop to monitor a web server nowadays, we send a web server request. We say, hey, give me that home page. And then we check the results to make sure, one, that it's a valid response, and two, that it has some key phrase in it. So we might make sure that the home page actually says Train Signal Inc. somewhere on it, just so that we know that the web server is functioning properly. Another really common monitoring application that we use is just Event Viewer. It's built into Windows. You can find it right in the computer management console, and it has just a ton of stuff you don't care about in there. By default, Windows logs a lot of stuff that you don't care to ever see. But it's also the most basic and simple form of monitoring software, and I'll show you Event Viewer a little bit later. No matter who you are, you're going to end up becoming familiar with Event Viewer because even on your own local computer at home, you'll have to look at it once in a while to figure out what's going on with your computer. Event forwarding is a feature of Windows and many other operating systems that will take the events you specify from the local event log and send them off to a remote computer. So while larger organizations will use some dedicated application to do event collection, small and medium-sized businesses often use this feature of Windows called event forwarding to take local event logs and send them to the event log on one particular computer, probably the IT guy's computer, right? At the bottom of the slide, I've listed 3 different major commercial monitoring applications. AppsView, Tivoli, which is IBM software, and Microsoft's big monitoring app, System Center. And these are just different enterprise apps, so if you work in an enterprise, you can check those 3 out as well as many others. These systems are far more sophisticated than simply Event Viewer or Event Forwarding. Not only do they collect the raw log files, but they'll analyze it for you and help you filter out the signal from the noise, and they have all sorts of different alerts and nice charts that they can draw. Anyway, they're really powerful. So let's take a look at some log files. This is the computer management console on a Windows 8 computer, and you see I've selected Event Viewer from within System Tools. So I'll dig in a little farther and look into the Windows logs, and we can see the standard Windows logs that all Windows computers have. And of these, the 3 that you'll usually use are Application, Security, and System. So let's look at Security first. What you'll see in here is just by default a bunch of audit successes. So in Windows you can configure auditing for a variety of different tasks, such as accessing files or logging in or changing user accounts. So whenever an event occurs where auditing has been enabled, Windows adds an event to the security event log, and it's either an audit success or an audit failure. For example, opening a file correctly would result in an audit success event. Attempting to open a file but failing because you don't have sufficient permissions, that would be an audit failure event. Successfully logging in, audit success. Typing the wrong password, audit failure. By default, Windows doesn't really enable any audit failures for some reason. It seems like those would be more important, but they're not turned on by default. So we can look through some of these and you'll see that, well, this computer has a ton of attempts to query for a blank account. And I actually don't know why this is occurring, but it definitely could be the result of an attack. Now, that seems unlikely since this computer's on an isolated network, but that doesn't mean that there's not an attacker on the network. So this is the kind of thing that you'd want to alert on and maybe respond to. And you might even set up a sniffer to see who it is that's querying for a blank password so that you could track it down. Now let's take a look at the application log. The application log is filled with whatever data that applications throw events for. So this is going to vary because it depends on the applications that are installed on the PC and what the developers for each application have decided to throw events for. It's entirely up to the individual developers. And here we can see some of those multiple levels I was talking about. You can see these informational events mean that you probably don't care about them. You might refer to them in the future. The app developer decided to make an event, but it's not important. Here's an error event, and it's because it couldn't load a particular library for a particular service that nobody really uses. Therefore, this is the kind of event that you don't care about. It says error, and it's got a red exclamation point there, but if I were an IT guy and I saw that come up on my screen, I would say, who cares? Nobody uses the service. I don't have time for this. So this is the kind of thing that you'd want to create filters for to simply ignore. On the other hand, if you couldn't monitor a more important service than the bits service, you'd probably want to know about that so you could respond to it, right? Take a look at the third log, the system log. This includes all events from the core Windows software. So you can see a lot of events that we don't care about. This particular event is saying that it couldn't set up the TPM hardware, but if you're not using the TPM hardware, who cares, right? Here's a warning, and it seems pretty serious with its like exclamation point and yellow triangle. Some driver failed to load for some USB device. I can't tell what device this is, but I could track it down using Device Manager, I'm sure. But all the hardware on the computer is working properly to the best of my knowledge, so who cares, right? This warning is saying that the network link for the gigabit controller is down. Sounds scary, it's got a warning, but this is a wireless computer and I don't have a physical Ethernet network attached to it, and that's why that warning is appearing. So you can imagine if you were an IT guy and you were getting alerted to that, well, you'd be pretty irritated. On the other hand, if it were a server and that were a critical wired Ethernet that was supposed to be working, well, you'd want to know about it right away, right? So this is why you need to go in and manually configure events and the reporting on it to kind of filter the signal from the noise. Now let's spend a few minutes looking at the performance logging capabilities of Windows 8, just so you have a general idea of the types of information you can gather and how you can examine it. I'm back in the Computer Management Console, and this time I've selected the Performance Monitor node within the Performance and Monitoring Tools part of System Tools. And before I started the Event Viewer demo, I set up a data collector set, which you can see here, to monitor the processor, disk, network, and memory utilization. So now let's open up that log file and see what kind of information was gathered. I'm just going to click the Properties button here and select the Source tab of the Performance Monitor Properties dialog box so that we can select the log file. By default, Performance Monitor monitors the computer in real time. So I'm just going to select the log file that I created here and click Open. Now, jumping to the Data tab, I'll click the Add button here, and we can see all the different data that I was logging. I logged the committed memory in use. the bytes you can get through the network adapter. Sorry, I had an item selected I had already added, so I'll click OK and then select only the new item, add that. And finally, I'll add the processor time. And now I'll click OK twice and I can look at the charted data. So you can see I only have 4 counters here, but there's more than 1,000 counters built into every Windows computer. And you'll see a lot of similar performance data can be gathered from just about any type of server and even networking equipment like routers. So first I'll select processor time, which is the yellow part of the graph here. I'm going to press Ctrl-H on the keyboard to highlight it. You can see that the highlighted item is now shown in bold black. This is the processor utilization of the computer throughout my event viewer demo, and you can see this is where I was most active, and indeed the computer was pretty busy. Then after I finished the demo, things quieted down a little bit. This is how busy the disk was. So you can see at periods here the disk was at 100% utilization. It had to query the log files, which are very large, and this is a pretty old and slow computer, so that took a few seconds. And you can see while I was browsing the log files, the disk was working pretty steadily. Once I was finished, the disk didn't need to be accessed anymore and the counters here dropped to 0. The green line here indicates network usage, and you can see that it's highlighted in black now. It's all against the bottom, which means that the network utilization was really low. Indeed, I was doing everything on the local computer, so there really was no network traffic. Finally, I'll select this, which indicates how much memory was currently in use on the computer. And you can see that it started out pretty low and gradually increased as I was using different apps. After I finished up the demo, I once again opened PowerPoint, so you can see the memory utilization went through a little jump here. But this is a percentage out of 100 of the possible amount of memory that an app could use, so it's still around 20%, so that doesn't indicate any kind of problem. I think performance monitoring, especially on Windows computers, is super fun. So go ahead and open up Computer Management, find the Performance Monitor console, and just look at the thousands and thousands of little pieces of information you can use and monitor. And think about how you might be able to use that in your own organization to head off problems and even detect potential security problems. This is Tony Northrup for TrainSignal, and thanks so much for watching this video lesson.